Okay, so welcome. Thank you for having so many new faces in here.
You alright? You good?
I am. How about you?
You seem happy.
I saw you rushing outside.
Yeah, I was because I forgot the cable on the other classroom.
Yeah.
Okay, so this is our last day. Come on. Yes. So this is our last class together. Theoretically, it will be that. However, it will be sad, but unfortunately, usually we say in Portuguese that it's always possible to go down a little bit deeper, which implies that you will have me again for macro, at least for the first 2 weeks.
That's cool. That's
Yeah.
good.
Is it?
That's good.
We will see. So, yeah, theoretically you will have Sinchan, but Sinchan had some personal problems. He's taking care of that, and therefore I will give these first 2 weeks.
That's good.
Okay.
That's good. Yeah.
And then he will come back, I hope, to teach you the last 4 sessions. Okay? I hope, because I continue to have this level of contact with you, then I will be invited for all your marriages. So let's indeed limit. So, David, come on. Now, yesterday I'm pretty confident that you were not able of understanding most of what I said for several reasons. First, your mind is elsewhere, and I know that very well. Okay. Second, I also know that this is new stuff and you will always struggle with this thing, okay? Because this is the most complicated thing in economics. So I was expecting you also to struggle with that. What I will do is the following. So I will then record on my own the lecture in a different way. And I will divide it in blocks, okay? So I'll make like a small recording just for what is in equilibrium, a small recording just for what is the dominated factors. Very short ones. The notes are already written, I already uploaded them on Blackboard. I adjusted all of them and I cleaned every piece of mathematics from them. Okay? So you have just the matrices like these ones in here, and then just basically columns. Okay? No notation, no functions, no nothing. Okay? Because I also understood from yesterday that that was perhaps also a point in which you were getting stuck. Okay? So we clean all of that. I will make these small recordings and upload that. And yeah, that is it. For my test on Monday. Pretty sad with the fact that I'm pretty sure that you did not study until now, okay? Do not synthesize you. What I expect you to do is just, my only recommendation is that do not just rely on the fact that you have a set of all the materials, okay? Because the questions that I will make will not be easily accessible on what you have on Blackboard. Okay? So it's just, if you study just for a little bit, if you take maybe Saturday and Sunday in the afternoon to study, you will not have any trouble with that. Okay? I can assure you. But if you do not study, then I'm already expecting that you will find that quite complicated. One more hint is that the last exercise is very simple, so you will get 30 marks, in my opinion, like this. The second exercise number 5 is not simple, okay? Sorry for you laughing, but I had to make something difficult, right? So that is not, but it's not simple in the sense, it is not mathematical, okay? It's just not simple in the sense that you will have to think a little bit how you will get the answer, but the answer is not mathematical. And then the multiple choices will be fine, in my opinion. Okay? But there will be lots of tricks there. So prepare yourself. And by tricks, I mean sometimes, I don't know, minus signs that are where they should not be, plus signs where they are and they should not be, these kind of things. Okay? So yes, I hope that you do well, okay? Because in econometrics, from what I can see, I don't feel you so confident about that. Okay, so at least we need to give you something positive, okay, at least at this stage. Okay, it is. So okay, so what we will do today is we will do 3 exercises that intend to precisely stress the ideas that we saw yesterday. Again, take these just lightly, okay? I know that you will perhaps not really understand everything, or you will not participate so actively as you were doing before. I understand that, okay? The purpose today is like trying to translate basically what I taught yesterday, okay? So let's start with this first game. So, first of all, the game is just, it only takes place in the mind of the players, okay? So no one is in fact choosing an action. No one is in fact taking a decision, okay? We're just thinking about what you will do, okay? So in this case, you have a game. The player that chooses either U or D is one player, and then you have another player that will choose the column, either L or R, okay? And depending on the actions that both choose, they will result on an outcome that is just the identification of the actions that each one has chosen, and then you get a payoff or a result from that, okay? So it means that, for example, if I choose U, you choose L, okay? The outcome will be UL. I will get 1, you will get 1, okay? And that 1 is the payoff, okay? Okay, so in that case, let's start by identifying the elements of this game. So how many players do you have? 2. How many actions do each player has?
2.
So the row player chooses between U and D, and the column player chooses between L and R. And how many outcomes do you have? 4. So you have U and L will be one outcome, U and R will be another, D and L will be an outcome, D and R will be another, okay? So these are the elements of the game. Now, I ask you whether there is an action that is dominated.
Yes.
Do you remember what is the meaning of an action being dominated?
It's like the one that the other player has more benefit than the other. The choice that you make.
Okay.
Yeah. For example, like DL, you get 0.6. So player D is more dominant than player U. No?
So you have one player in here, another one. Tell me.
Oh.
Is it one outcome that will always be selected over another outcome by both players?
That will be an equilibrium. Okay. So an action that is, let me see what. The option that gives you always a higher payoff no matter what the other player does. Okay. So that's absolutely correct. Let's take this action D. You are the row player. If the opponent chooses L, you will always get 0, but if you have chosen U, you will get 1. So that was not a very good choice of you. Okay? If your opponent chooses R, you get 5. But if you had chosen U, you will get 6. Okay? So we say that action D is dominated by action U. That is, action U is always better you should always choose that action because it will always give you a higher payoff independently of what your opponent may choose. Does it make sense? So in that case, you say, okay, I will never choose D, because if I choose D, my opponent chooses L, I just make 0. I could have made 1. If my opponent chooses R, I make 5. I could have made 6. Okay? Yeah? So we say that action D is dominated. Okay? You can think of an action that is not good. So there is no point on choosing that. And action R, what do you think? Is also dominated? What is your opinion? Should the column player, if you are the player that is choosing the columns, should you ever choose R? And why not? Exactly. You will always get a lower payoff than what you can get if you choose L. Okay? So in this case, we say that both actions D and actions R are dominated. Okay? And if you are rational, your objective is to maximize your payoff, is to get the best result possible. So will you ever choose D or choose R? So if you are the row player, the one that chooses the rows, will you ever choose D? No, because it will always give you a smaller payoff. If you are the player that chooses the columns, will you ever choose R? No. So because we say that you will never choose that, you can eliminate those actions from the game. Okay? Because they will never be chosen. Okay? So you can simplify the game matrix. Now, I ask you then, and the questions that I'm falling in here are the questions that you will always see in an exercise that will appear on the exam. Okay? Always like this. So, I then ask you what is a Nash equilibrium. Okay? We spoke of an equilibrium in competitive markets. We always said an equilibrium is a situation where neither the supplier or the consumer have an incentive to do something different, right? They do not have an incentive to buy more or to buy less, and the supplier does not have an incentive to sell more or to sell less, right? In here is very similar, is that the players will not have an incentive to do something different. So, do you think, to start with, that the player that chooses the rows choosing U and the player that chooses the columns choosing L will be an equilibrium?
Yes.
Why?
Because when the right player chooses U, player 2 has an option between either L or R. L has a value of 1, R has a value of 0. So it's going to choose L at the time.
Correct. And now from the column perspective.
Well, again, column player can choose between R or L, right? And they'll always choose L over R because R is dominated by L.
So if the column player chooses L, then the row player also does not have an incentive to choose D, just to choose U because the payoff will always be higher. Okay? So we call that an equilibrium. And the best way of finding an equilibrium is by identifying the best replies. That is, you say, I am the row player. If I choose, I am the row player. If the column player chooses L, what will I choose? U. If the column player chooses R, what will I choose? U. Okay. Then the column player thinks, okay, if now the row player chooses U, what will I choose? L. Okay. Because if you choose R, you get 0. Then you say, okay, if the row player chooses D, what will I choose? L or R? L. Therefore, the outcome where everyone is best replying to each other is an equilibrium. Okay. Fine. Sure. So we said that an equilibrium is U, L. Okay. Is it fine? It's yes or no. Do not need to lie. Tell me. You are yes, but you are no, right?
Yeah.
You get?
Yeah.
Okay. So we say that U is the best reply to what the opponent will do. Okay, so U is the best reply to the opponent choosing L. Okay, and L is the best reply to the role player choosing U. Okay, so that is why we call U a best reply against L. Fine? Yeah? Good. So these are, you will always have a game like this. This is a game matrix. You will always have, I just give you two players, always to simplify. Each player will only have two possible choices, and they will always get a payoff from that, okay? An equilibrium is what we expect will happen, okay? So because some of you yesterday asked me, okay, but look, but we do not really know what my opponent will indeed choose. So how can we make even any prediction? The Nash equilibrium is that. The Nash equilibrium is a way of identifying what will happen without exactly knowing the probabilities of your opponent choosing each action. Okay? So a Nash equilibrium is just a way of eliminating the uncertainty. Okay? Because when you look just to a game, you do not know what will happen. If you identify a Nash equilibrium, you know that that will be the outcome that will be verified in reality. Okay? Just that. Yeah. I am afraid that some of you may pass out during my class. I will thank Peter and I will thank Joel for their services. Okay, let's now look at this game in here. So you have one player and you have another player. The player that chooses the rows chooses either D, U or D. The player that chooses the columns chooses either L, C or R. Depending on what they will choose, they will end up in a given outcome and they will make some money out of that. Okay? You can think of the payoffs as money if that helps. Okay? So again you have, and I will skip this part A by saying you have two players. The player that chooses the rows has two actions. The player that chooses the columns has three actions. And then you have six outcomes. Okay? Now, can you immediately identify some action in here that is dominated? That is an action that you should never choose, independently if you are the player that chooses the rows or the player that chooses the columns. And I want just to make also a small, I want just to say small. That is, so one of you, for example, was speaking with me and was saying, you know that this is very complicated because we do not come from economics. Bear in mind that this that I'm teaching you is mainly applied outside of economics, in political science, in international relations, and all these kind of things. Okay? So just for you then not to think that only in economics we are crazy enough to use these kind of things. So can you identify an action in here, either U, C, L, D, or R that is not good? Something that you should never choose? R. And why is that? You are correct. Yeah, okay. So if you are the player that chooses the columns, you think to yourself, if my opponent chooses, you are absolutely correct, Benjamin. So if your opponent chooses U, you say that if I choose R, I will make 1. If I choose C, I will make 2. Therefore, I prefer to choose C in that situation. Now, if my opponent chooses D instead, if I choose C, I will make 1. If I choose R, I will make 0. So you can see that C will always guarantee you a higher payoff. Okay? Therefore, if you then face this situation, you know that player 2 will never choose this action in here. Okay? So you can eliminate this action from the game. In this situation, is now any action that now should not be played? And why is that?
Because if you're playing white, you know that R has been pushed out, then it's either the person with the L, if they L, then you know that they can get you better than 0, and get 1. If they C, then you know that playing you will get you better than 0, and get 1.
You're correct. Okay? So, you know that every time that you choose D, you will always do worse than if you choose U. If your opponent chooses L, you will always choose U, because you will make 1. If you choose D, you will make 0. If your opponent chooses C, you will make 0 if you choose D, you will make 1 if you choose U. Okay? Therefore, you will never also choose D. It's not a good action. So we eliminate that also from the game.
Would you call that one dominated as well?
Yes. Okay. What we are doing now is, instead of me providing you with a theory that is iterated dominance, just giving you an example because I think it is easier in that way. Is any action now not good? So L now is not a good action, right? Because you know that the player that chooses the rows will always play U. In that case, you will never play L. Okay? This thing that survives is a Nash equilibrium. Okay? So this is another way of getting a Nash equilibrium. Make sense? Yeah? Good. And that is the unique one. And so whenever you just have a unique one, you cannot have an equilibrium in mixed actions. That is what I will speak after, okay? You just have that one, dot. Okay?
You go over the last solutions again, this is why L was dominated.
Marcus? So the row player will always choose U. Therefore, what will you choose?
You choose C. Because you get 2.
Therefore, what is L in that case?
So you remove L.
Yeah. Then L will never be played.
So that is a dominant action, isn't it?
Exactly.
So we have 4 dominant action.
You have one, two, you
R.
have 3 dominated actions. So the first one was R.
UL.
You are thinking of outcomes. When you say UL, you are saying an outcome.
Yes.
If you just say U, it's just an action. Yeah?
So it will be R and L.
So it will be R is dominated, then D is dominated, and then L is dominated. Yeah?
So there are 3 dominated actions.
Yes. Okay. So the procedure that we followed now is what we call iterated dominance. Okay? Is that we go like one step, okay? Eliminating whenever we can. Okay? And this is how people usually think in reality. Okay? So when you are facing a problem, usually you tend to eliminate some options that you consider that are not a good idea. Okay? So you eliminate them. If your opponent knows that you will never choose these kind of things, he will also adjust the actions that he might choose. Okay? And usually people behave in that way until they reach one final result. Okay? Yeah? Good. Peter there yesterday paid me my bus ticket. Like, you already saw this. I have now students paying the bus ticket because I could not pay. See immediately how I am being treated by this university. Okay. So, and Peter now will benefit from that, of course, by surely passing the test. Okay. Final one. This is also a popular game. It's called Ockendorf. It is a game from biology. Okay. So in biology, game theory is very important because it allows you to understand, for example, which viruses will survive, which bacteria will become more resistant. Okay? Because you do not need to have human players. You might assume that you have, for example, COVID alpha variant against COVID delta variant. Okay? And what will happen is that each virus is programmed to do something, to infect people, for example, more faster than the other. Okay? And so, for example, you can imagine that if that is the case, the payoff of this delta variant will be higher because it can spread faster. So it's just to give you an idea of applications that spread way away from economics. So in this case, we just have an auk and a dove. You just have, it's like you have two animals. One animal, you may choose to be very aggressive, so I call you an auk. Or you may be a pacifist, and then I call you a dove. Okay? So this is also used in international relations when, for example, you are evaluating the possibility of a war between two countries. And you might think whether the country will be aggressive or not. So this was the kind of game that we were using in the 60s to determine the possibility of a nuclear war between the US and the Soviet Union. Because you can think of being hawk as like nuking the other country, okay? And if that happens, if you can imagine that you have the US in here and the Soviet Union in here, give me just a moment. Okay. Let me just mute someone in here.
I didn't.
Okay. Yes, Edna, I will provide the recordings. So you can think that you have the US and the Soviet Union. And you can think that Hawk is like launching a nuclear attack against the other countries. And then the Soviet Union also chooses the same thing. Then they destroy each other and they get zero, their country disappears. Okay? Then you might think that if the US nukes the Soviet Union and the Soviet Union decides to be a pacifist, but they were not, but let's suppose that they were, okay, then the US would win, okay, and the Soviet Union eventually will lose, but will not be completely destroyed, okay? For example, the US could say, okay, fine, we already won the war, we do not need to completely obliterate you, okay? Then you can think that it could also happen that the Soviet Union will launch an attack and the US, you will not, okay? In that case, the Soviet Union would win and the US, you will lose, okay? And the outcome that we were always hoping that will be the case, will be the one verified in reality, is that no one will attack each other, okay? And therefore, both survive, even if the payoff is not as large as it could be. Because you can imagine that if you are able to defeat your opponent, right, then the payoff will be larger, because you no longer have an opponent, okay? In that case, it is 2 and not 3, because the opponent continues to exist. They may still then launch a nuclear attack against you. Does this make sense, this interpretation of the game?
Yeah.
Good. So, and this was, it might seem a bit stupid, but this was the high tech of mathematics in the 60s, okay? And this was what we were relying to make decisions and to advise the US president and the Soviet Union leader, okay? So Nikita Khrushchev and should be Nixon maybe by that time, okay? So the elements of the game are again trivial. Have 2 players, you can call them Soviet Union, US if that helps, okay? What is good with game theory is that matrices are something that you can always apply to the problem that you want. So you can always call the players as you wish. If you want to call them US and Soviet Union, fine, good, no problem, okay? So you have 2 players. Each one has 2 possible choices. You can think of a nuclear attack or not, being an hawk or a dove. And then there are 4 possible outcomes that we saw. So they may destroy each other, they may both of them coexist, one may win and the other one may lose, and vice versa, okay? And that's the game. These are the elements of the game. So is there any action in here that you see as being dominated? The best way to see this, hawk is dominated by dove. Do you agree that hawk is dominated by dove?
Yes.
Yes.
Why is that? So let's suppose that your opponent decides to attack you. What should you do? In that case,
You should launch.
no, in that case you should not do anything. See? At least this is what the matrix is telling you. I'm not saying that this is what the country should have done in reality, okay? In this case, this. Now, if the Soviet Union shows as being weak, then indeed you should take advantage of that and you should attack him. And in that case, you will choose hawk, which the payoff is 3 instead of 2. Okay? So you cannot say that there is a dominated action, okay? Because each action will be useful in some situation. Okay? Makes sense? Because hawk is a good idea if you think that your opponent is weak, is a dove. And being a dove is a good idea if you think that your opponent is too aggressive and he will attack you. You will be a hawk. Okay? To be dominated, it means that the action is never a good idea. Okay? But in here, it might be a good idea. Okay? At least in one situation. Yeah? Fine?
Excuse me.
Yeah.
So as the US, they will never be involved because whether the Soviet Union choose hawk or dove, US should be a hawk. It will never be a dove.
Why not?
Because if the Soviet Union choose hawk, the US will choose hawk. It's the same. Why?
Why? What is the payoff that you get in that situation? 0. What is the payoff if you choose dove? 1. Then you should not, okay? So the idea in here behind this game is that both countries should not attack each other at the same time, okay? Because both will lose in that situation, okay? So the equilibrium that you have in here is the following. And again, I advise you to follow these. What I always give you are like algorithms, okay, or cheat codes to find the solution. So you say, I am the US. If the Soviet Union decides to attack me, what should I do? Nothing. If the Soviet Union does not attack me, what should I do? I should attack him. And now you put yourself on the shoes of the Soviet Union. And you say, Okay, now if the US attack me, what should I do? Nothing, okay? Because otherwise I get 0. And if the US does not attack me, then I should attack him. So you have two equilibrium in this case. One equilibrium is that the US will attack and the Soviet Union will not. And the other one is that the US will not attack and the Soviet Union will. Okay? Fine. This also serves as a lesson for you not to take too much into account your own perceptions about what is reasonable in reality. Okay? This is a branch of mathematics. We rely just on the numbers that you see on the matrix, not on what you think may be more reasonable. Okay? I speak by experience because I did first a bachelor in economics and then I was stupid enough to go for a master in applied mathematics. Then, thanks to God that I was smart enough to understand that I should return to economics, and that is why then I did a PhD on that. So you can see the point. Now there is one more equilibrium in here.
0, 0. Two is the equilibrium already.
No.
No?
That is another lesson. 2 is what we consider to be the more fair result, right? But being more fair does not mean that it will be an equilibrium. An equilibrium is what we expect will happen. You know why it is not? Because each country will have always an incentive to nuke the other.
Okay.
So if they are just in peace, imagine that they are in peace. If you are the US, what should you do in that case? Attack. Your payoff moves from 2 to 3. Okay. How do you access? I will upload it. I did not upload yet. I haven't uploaded yet. Don't worry. Yeah. So there is one more equilibrium in here, and this is something that yesterday was the moment in which I can tell you that I thought I messed up, okay, because I should not have thought that. So there is a mixed equilibrium in here. That is now when you do not choose an action with 100% probability. You choose an action just with a certain probability. So let me explain this a little better, especially because David is cringing because he was not yesterday on my lecture.
Would you choose pork because, as you mentioned, if you choose, or if you choose pork, you want to lose 1, but they would lose 3. So you have incentive to go for pork.
Okay, I can see what you are saying is something that I will not teach you in here, okay? But it's something that in game theory we call social preferences. That is, when I get some pleasure from you losing something, for example, okay? But I'm not considering that in here. This is something that then we do research, okay? I do research, for example, my research is on how emotions will affect the kind of decisions that you will make, okay? But I do that from a mathematical standpoint, so how envy or aggression or guilt will affect the kind of action that you can take. This just goes to the point that yes, that might happen, okay? But we will not take that into account in here, just the matrix, okay? And just the numbers. Okay, so we are right on time. I know that there is one more equilibrium, but I will not show you because do you want to see it in here? Yeah? Okay, in that case I will show you because I look at your faces, you are like almost sleeping. Good, okay, this is the first time that I have students asking me to stay beyond the hour, but okay, let's then proceed. So, now you have two equilibrium, okay, that's for sure.
Yeah.
you have a third one, and this is something that is difficult for people to understand, okay? It's not only you, any student struggle with this, okay? Because the concept is a bit weird. Let's think of the following. Let's think that you have a goalkeeper. You have a guy that will take a penalty kick. And let's assume that he only has two options. Either he shoots to the left or to the right. If you are the guy that will take the penalty kick, what should be the probability that you will shoot to the right and shoot to the left?
So the goalkeeper is leading to his.
He's like in the middle. You cannot really say anything about the goalkeeper.
What's the probability of choosing left or right? 50%.
Makes sense, right? 50-50, because then the goalkeeper does not know what he should do.
Exactly.
That is a mixed equilibrium. What you said right now.
That's what?
You want to know why?
This is mistake.
Tell me.
I really want to know why because I was very.
Oh, you were a goalkeeper?
Yeah.
I was also a goalkeeper growing up. Okay. So you speak like being of my height, right? Because I was playing futsal. I was not playing football.
Smooth nets.
May I continue? Let's go. So that's a mixed equilibrium because the notion of equilibrium is that no one has an instant. This equilibrium is that you will block your opponent. That is, you will make your opponent helpless. This is the idea. Okay? This is the idea behind the equilibrium. This kind of equilibrium is that you choose the actions in such a way that your opponent does not know what to do. Okay? And he thinks to himself, okay, either option will be valid. This is the idea behind the mixed equilibrium, is that you are trying to eliminate the uncertainty. This is always the objective. You want to eliminate the uncertainty. And this is the way, is you choose the actions in such a way that the opponent does not know what to do. In that case, there is no uncertainty, okay? He just says, okay, I don't know. He may just go to the left, he may go to the right. Let me show you how that works mathematically, okay? So we assume that the US has a given probability of launching an attack and of not launching an attack. The Soviet Union has a given probability of launching an attack or not. Then what will happen is that the US will choose the probability of launching an attack such that the payoff that the Soviet Union would get from launching an attack is equal to the payoff that the Soviet Union will get of not launching an attack. You can think of the goalkeeper again.
Okay.
So the US will choose these two options with such a probability that the Soviet Union will not know what to do. Okay? They will become indifferent between the options. Okay? So it means that the payoff that the Soviet Union will obtain if they decide to attack will be equal to the payoff that the Soviet Union will get if they do not attack. Okay? This is the idea. It's like the goalkeeper. The goalkeeper is indifferent because he knows that the odds of defending the penalty kick are the same. Okay? Either if he goes to the left or goes to the right. So this implies that this payoff in here is 0 if with probability P, that is the probability that the US will launch an attack, plus 3 with depending on the probability that the US will not launch an attack. Okay? And this has to be equal to 1 times the probability that the US will attack you, plus 2 times the probability that the US will not attack. You get this? Makes sense? Mathematically, it's always like this. That is, you are calculating the payoffs of one player using the probabilities of the other. That is, the goalkeeper is thinking about the probability of defending the penalty kick, taking into account the probabilities of the guy that is taking the penalty kick. Okay? So you are thinking about the guy that is shooting, not about your own odds of defending the penalty, of going to the left or going to the right. Yeah? So if you simplify this, you just get 3, 1 minus P, P plus 2, 2P. Now, 3 minus 3P minus 3P plus 2. Okay? I already messed this up.
Now it's that.
Minus P. 3 minus 3P equals to P.
Oh yeah, sorry. Yeah, you can see that even I am already messing this. So this will give you 1, and it will give you in these sides 2P.
50%.
Yeah? Okay?
So in this case, P is 50%, but for the equilibrium one, on the example is which one?
The equilibrium in this case, you say that is that the US will choose to launch an attack with 1/2 probability, not launching an attack with 1/2 probability.
The new one you need to.
Yeah. And then you will calculate.
So we suppose it's 50% to 50%.
Yeah. Okay. If then you calculate the payoff of that, okay, you think to yourself, if the US chooses these things with 50%, then the payoff that the Soviet Union will get whenever they launch an attack is 1/2. That is 0 times 50%, 3 times 50%. That is 1.5. So it will be 0 times 50% plus 3 times 50%. This is 1.5. If they decide to not launch an attack, the payoff will be 1 times 50% plus 2 times 50%. This is?
So the action is the same, the payoff is different, is that what you mean?
No, the payoffs are the same, as you can see. It makes 1.5 the Soviet Union if it launches an attack.
Yeah.
It makes 1.5 if they do not launch an attack. Yeah?
It's just sort of taking the average of the possible.
You are just taking the average, yes.
The average of the possible decisions like that, and Paris states.
Yes.
I understand. Because you're sort of like an opportunity cost, isn't it? Isn't it, if you choose to be a hawk, you could choose to be a dove as well. Sort of calculate those.
Exactly, yes. Yeah? Okay.
It's just like, so when you frame it in the context of what the US could do, that confuses me a little bit. But it's just, if you're just looking at, I don't know, what the Soviet Union could do, isn't just their actions. That makes more sense. Because it's just you analysing their actions and their actions only.
Of course.
See what I mean?
I understand what you are saying, but the actions that the Soviet Union will choose will depend on what the US will do. This is what you are taking into account in here, okay? So what you have in here is that if then it is equally likely that the US will attack you or not, then you, as being the Soviet Union, you also become indifferent between attacking them or not.
Excuse me, so is this the third equilibrium?
Yeah.
Means there is no actions.
There is actions. You choose with 1/2 probability hawk and with 1/2 probability dove. And with 1/2 probability hawk and 1/2 probability dove.
I think it's something about the possibility, it's not a real action.
It's not a real action.
No, it's just a...
It's just a possibility, yes. That is why I said yesterday that I call this a mixed action. That is precisely to call your attention. It's just a possibility. What you are saying is that in reality they will choose something, right? They will attack or not.
Isn't it hawk dove and dove hawk? It's basically the same action, yeah.
Yeah, it is. So That is the first one is the action of the US, the second one is the action of the Soviet Union.
Oh, okay, okay.
Yeah?
I see, I see.
Is it okay? Do you have any questions concerning the mock exam if you have already looked at that?
So the 30 mark questions, those are essays that we have to write on a specific topic. So there are some questions, I believe there were 2 questions you said, right, that 30 marks each, is that what it was? Is it just like one question?
No, you have to answer both.
So 2, that were.
Yes. Plus, each one is worth 30, and then you have an additional 40 marks from the multiple choice, where you get 3 marks from getting the option correct and 7 marks for the justification.
So,
And you might understand that I'm doing that because you will do this exam in group, and therefore you will get the answers correct, but the justifications you cannot copy from each other, right? So tell me.
so answers to multiple choice scoring, and the other 2 30 mark questions. they're
Yes.
essays,
Hmm?
Right? So the other 2 30 mark questions are essays, right? Or they not?
Oh, so you haven't opened yet the document that I uploaded? Okay.
No.
No, they are exercises. They have like 4 questions each. That is like a way of giving you marks. Like what will happen is that you will have like some questions that are very easy, like to give you the marks. Already something. I don't know, each one is worth 30. You will always, in my opinion, get 15 like this in a matter of 2 minutes. And the other 15, perhaps you will take, I don't know, 20 minutes to get that. Okay. In total, I do not expect you to spend more than 2 hours if you have studied that. If you have studied, you will not spend more than 2 hours for sure. Okay. If you did not study, which is likely as well, because you have other things to do, then you might take a bit longer because you will have to dig into the lecture notes and search for the answers there. Yeah?
Yes, sir.
Anything else that you want to ask? No? Then take care.
Yes. Have a good weekend, sir.
Yeah.